The world is now rapidly waking up to the importance of making chemicals and chemistry more sustainable and environmentally compatible. Here at York, we've been working towards solutions to these challenges for many years. The Green Chemistry Centre of Excellence has recently been presented with the 2013 Green Gown Award for Research and Development.
The Green Gown Award acknowledges York's constant commitment to green and sustainable chemistry. We're really delighted to receive it.
Within the Chemistry Department, the Green Chemistry Centre of Excellence is an internationally leading facility for pioneering pure and applied green and sustainable chemical research.
So the history actually goes back quite a long time. So I got involved in green chemistry way back 20 plus years ago, working with the chemical industry and understanding their challenges, the opportunities to create new, greener alternatives for hazardous reagents. So we started in York around about the mid-90s to start talking about green chemistry, to talk to industry more about green chemistry. And then in 98 was probably a landmark year because we started the Clean Technology Centre, as it was called then, here in York. We also started the Green Chemistry Network, funded by the Royal Society of Chemistry. And the next year, very exciting, we started the Green Chemistry Journal. And it's moved on from there up to now 2006, when it actually became the Green Chemistry Centre of Excellence, fully endorsed by the regional government and by the university, and it's growing all the time. So we started the master's course in 2001. It was all very much part of the green chemistry startup at York. It was completely new, there was nothing like it in the world, but it's built up into a very substantial course now.
I think the special thing about the MSc here at York is the fact it gives a good opportunity for students post-undergraduate level to actually work with somebody in industry. Well, like the workshop here that I'm running today about the complexities of actually putting a chemical manufacturing process in place these days. And I think there's a realisation now that green chemistry can actually be of benefit to commercial organisations such as the pharma industry.
So the master's course actually is based on a 6-month taught element and a 6-month research project, more or less. And the research project enables the students to actually get into the research laboratory, do projects in collaboration with industry, learn how to teamwork, learn about the modern green chemical technologies, and this has been very successful. And this is part of our research activities in the Green Chemistry Centre, which are very large. We now have about 30 PhD students alongside the 20 master students, and a large number of senior researchers from postdoctoral, fresh PhD students, all the way through to more experienced researchers working together on a whole range of green chemical technology opportunities.
Within the centre, we have 4 technology platforms: renewable materials, clean synthesis and platform molecules, microwave chemistry and natural solvents. All of these are encompassed by training, education and networks. This platform facilitates interactions and collaborations between the Green Chemistry Centre and external stakeholders. Networks are at the heart of forging new collaborations and promoting innovative research.
Big projects in the lab at the moment include an Innovative Medicines Initiative project we call Chem21, which is in collaboration with many partners in industry and also around Europe. And that's all about trying to make the future generations of pharmaceuticals and the people who make pharmaceuticals greener, to be more aware of what these opportunities, what the challenges are for the future with regards to lowering the environmental impact and making drugs more sustainable. We also have a very growing activity in and around the use of food waste. We see food waste as a wonderful opportunity for providing renewable carbon. There's a lot of food waste all over the world, and we think that we can actually use our green chemical technologies to extract chemicals from the food waste, and those chemicals can be used to displace a lot of chemicals that we use today which are not sustainable and derived from petroleum. We've also got a very exciting new area starting around metal recovery. So one of the projects we have is another nice collaborative project involving several partners, and this is about what we call phytomining. It's using plants, their ability to naturally capture metals from the ground, from waste streams, and then we take the plant containing the metal and then convert that into something useful, like a catalyst, for example.
The group's close links with a wide range of businesses mean that promising projects can be further developed with industrial partners with a view towards commercialisation.
We've got some fantastic examples of projects that we've started off at discovery research and delivered all the way through the pipeline through to commercialisation. For example, we've been in a great project looking at waste wheat straw, where we've taken waste wheat straw and we've converted it into what we call a bioboard. So this is what we made in our lab, and then that's on to commercialisation. This board here is truly sustainable and reflects our research. The board is made from wheat straw, it's urea, isocyanate and formaldehyde free, and everything inside here is sustainable. And this hopefully will be on sale in our shops within the next 15 months, and that's a remarkable achievement. We also now have a spin-out company called Starbond Technologies Limited, where we take waste polysaccharides and we convert those into mesoporous carbonaceous materials. And these materials are now being used for water treatment, water purification, and you can see the need for fresh water globally, which also tells of the impact of our materials that the materials are making.
A key part of working towards commercialisation is the ability to test feasibility on a larger scale.
So here at York, we recently started our new Biorenewables Development Centre, and this is the first serious attempt we've made to demonstrate our green chemical technologies at scale. This centre opened last year. It was opened by a government minister. It's a €10 million project with some wonderful equipment allowing us to really take our ideas further forward. And this is now alongside our brand new Green Chemistry Centre, which we move into early next year. This is a state-of-the-art research laboratory. So we have a much greater space, we have a much larger laboratory than we've had in the past. And very interestingly, we have something called an industrial engagement facility. This is something completely new, we think new to the UK. And it's an area where industrialists can come in and work with the scientific staff to really allow them to see better exactly what we can do and what we can do for their companies. We've been very excited about the progress, the developments, the exciting discoveries and breakthroughs we've made in the Green Chemistry Centre in recent years. And we were especially delighted to be given a Green Gown Award for 2013. We are very pleased and very proud to receive such an award.